Today's topic is projectile motion, and projectile motion is a really cool topic. It may seem complicated, but knowing how to calculate projectile motion problems are very important, not only in physics, but in science in general, to find out the movement of objects as they're moving through a certain amount of space. So a projectile is any object moving through air affected only by gravity. So it has to do with free fall and beyond that. So for example, kicking a soccer ball, a stunt car driving off a cliff, a skier going down a ski jump. These all have to do with projectiles. So in projectile motion, when we're talking about trajectory, that's the path that projectile follows. So for example, here, the trajectory of the basketball is shown here in this shape. And that shape is called a parabola, and this is a bowl-shaped curve. So when you throw a ball, usually when you throw a ball, it's going to be curved. So for projectile motion, we have a range, and that range is in the horizontal distance. And this horizontal distance is before it touches the ground. If you're asked to calculate the range of a projectile, what would you be calculating? So if we're asking for horizontal, this range, we're asking for horizontal distance. And we've done that, we've calculated horizontal distance before. So projectile motion is 2D or two-dimensional because we have a vertical up and down and a horizontal left to right at the same time. For example, here in the cannon, we have horizontal motion here, and then we have the projectile motion, the parabola motion as it goes down. And we know that it's as soon as it lets go, remember, it's in free fall because gravity is pulling down, and that's why we have this shape. So the horizontal and vertical components are independent. So that means that whatever is in the horizontal is not going to affect the vertical, and the vertical is not going to affect the horizontal. So does the horizontal component affect the vertical component? Does the vertical component affect the horizontal component? So when we look at our shape here, and this is color-coded, so you might want to color code on your notes as well. We have the parabola, which is in red, and it's curved. And we know it's curved because as soon as we let go, gravity brings it down. Okay, and we have our horizontal component in green, and we have our vertical component in Y. Okay, so horizontal and vertical are independent of each other, so it doesn't matter if we calculate horizontal, that's independent of our vertical. So both speed and direction change as a projectile moves through the air, and that makes sense because as we're moving, as this ballistic ball is going down, our direction is changing each second, and then also the speed is changing as well because pretty soon it's going to stop moving. So the motion is easier to understand by thinking about vertical, up and down, and horizontal components separately. So we always have to think of these two components separately. So for projectile motion, we may be asked about the vertical or the horizontal or both, so it becomes a two-step problem. So for projectile motion, when we're dealing with the x component or the horizontal, we use our speed formula, which is velocity equals distance or displacement over time. And for the y component, or for the vertical component, it just becomes a free fall problem, which we just went over. And we use this formula for the y-axis. So this is for x, and this is for y. So depending on what they ask us, whether they ask us for horizontal or for vertical, we use that separate equation. So is a ball rolling off a table a projectile? Yes, it is. So let's look at this picture. When you roll a ball off a table, as soon as it leaves the table, gravity takes over and it pushes it down every second. And we notice that we have horizontal and vertical components. So once the ball becomes a projectile, it feels no horizontal force. So its horizontal velocity is constant. So what does that mean? That means it moves the same distance horizontally each second. It moves horizontally in the air just as it would on the ground. So horizontal velocity, just like in that picture, and in your notes, you notice that the horizontal velocity stays the same. It is 5 meters per second each time. So a projectile's horizontal velocity does not change because there is no horizontal force acting on it. There's nothing from left to right moving it at all. On the other hand, the vertical motion of the ball is accelerating because of gravity. Gravity takes over and it becomes a free fall problem at that point. So what is a ball's rate of acceleration? So just like any other free fall, the vertical speed increases 9.8 meters per second each second due to gravity. So gravity gives the ball an acceleration of 9.8 meters per second squared, only in the vertical dimension only. So a projectile's vertical velocity increases by 9.8 meters per second each second. So it just becomes like a free fall problem, and we've gone over this in the free fall video. So what is happening to the horizontal velocity of the ball? So horizontal stays the same. And what is happening to the vertical velocity? Vertical velocity also changes every second due to the fact that once it's off the table, it's in free fall and gravity takes over. And we change the acceleration by 9.8 meters per second.